Hey, Physics 111. All right, I want to do one last video, just pretty short, about loudness or intensity of sound. This goes with chapters 16 and 17 on waves, and this goes with numbers 28 and 29 from chapter 17. All right, so when we talk about how loud sound appears to us as humans, where it turns out our hearing is not particularly good at determining just how much more energy is coming in. And so, as physicists, we're more interested in energy, how much energy is in the wave, is being delivered by this wave, because waves deliver energy. So we're detecting something like energy when we think about how loud something is. The louder sound does have more energy, but it doesn't have the same multiplication factor that we sense it to be. So, okay, as physicists, we're going to call intensity capital I. So capital I is intensity, and this is the energy received from the wave divided by time, so per second, per area that's exposed to the wave. And, in our hearing points of view, this is actually usually the area of the eardrum. Which is a pretty small little area, just inside your ear. So there's a drum in there that has some, or a little kind of skin barrier that has a certain cross-sectional area, and that's what we're talking about. But intensity could be measured with something else instead. You could have some sort of other detector that would have some sort of area that's collecting this wave. So the more wave, the more area that's exposed to the wave, the more intensity you're going to get. We do have a standard reference intensity called I sub naught. This is not an initial intensity. This is just some base intensity energy. And this is basically near the lower limit of human hearing. Some humans can hear a little bit less. Some humans can't hear that low anymore at all. Your hearing intensity does drop, or your ability to hear soft noises does change as you get older. The units, by the way, here, of course, are going to have energy units on the top, time units, and area units on the bottom. So joules per second per meter squared, or meter squared. And because a joule per second is a watt, technically you sometimes will see it written as watts per meter squared, but I don't like watts. We've talked about that. Human hearing has evolutionarily developed so that we can actually hear an extremely large range of intensities, where, again, the lower limit is something like 10 to the negative 12 joules per second, which is it's a very small amount of energy, right? I mean, that's extremely small, and that's per square meter. The human eardrum is not anywhere near a square meter, and so we're really detecting tiny amounts of energy as in these sound waves. And then we can go all the way up to 10 to the negative 4 joules per second per meter squared, safely. You can hear louder noises than that, obviously, but it's not a safe thing for your eardrum to do, at least not continuously. Now, this number is 100 million times larger than the lower one, right? This is 10 to the negative 12, this is 10 to the negative 8. It's 10 to the 8 times more. And so that is 100 million times the lower number. But it doesn't sound 100 million times louder to us. I don't even know how you would to deal with that. 100 million times is a lot for us to have as a thing. We would sound louder, but it wouldn't sound that much louder. And it doesn't do that because our hearing is logarithmic, which basically means we take the logarithm. Our brains take the logarithm of how much energy is coming in. And then that's sort of what we sense as the amount of sound that we're getting. And so a sound that's 10 times larger in intensity may only sound about 2 times louder to us. The actual equation, so instead of using intensity to denote loudness, so intensity is sort of what physicists are interested in, if it's not their ears. But as a human, we really talk about the decibels or the sound level. So beta, which is actually just called the decibels of the sound or the sound level, goes with this equation where you say basically you have the intensity of your incoming sound, you divide it by the base intensity, the reference intensity, and then you take the log of that, and then you multiply it by 10, and this little symbol right here, little d, capital B, is a decibel, so 10 decibels. And that will tell you the decibel sound level limit, or the amount of decibels that are coming in. And so we talk about sound level that way. I thought we could go ahead and do this problem real quick, number 28. So it says 2 sounds differ in sound level by 1 decibel. So that basically means that sound level 2 minus sound level 1 is 1 decibel. Well, sound level 2 should be 10 decibels log of sound level 2 over the reference intensity. And similarly for 1, I1 over I0. So if I put these in here, say 1 decibel, and I write this all out, I'll say 10 decibels log of I2 over I0 minus 10 decibels log of I1 over I0. Let me bring the 10 decibels out. And then I have log of I2 over I0 minus log of I1 over I0. And this is where it's worth remembering the things one can do with logarithms when you're subtracting and adding them. So the log of, let's say this, A minus the log of B is actually equal to the log of A divided by B. Right? When you deal with logs, you can do all kinds of wacko stuff you can't do when it's not in logs. And so I can rewrite this side as 10 decibels log, and I end up with a huge fraction here. I'm going to have I2 over I0, the whole thing, divided by I1 over I0. And so then I have I0 on the top and the bottom in here, and I end up with just 10 decibels log of I2 over I1. The I0 part goes away. And so I can solve this now. I can basically say, okay, well, the log of I2 over I1 is 1 decibel divided by 10, which is just 0.1. Oh, just a second. Let me look at my calculator. Okay. And so then I2 over I1 is just 10 raised to the 0.1. Right? And that's what it's trying to do. What's the ratio of the greater intensity to the smaller intensity? That's what we've got right here. So inverse log of 0.1 is 1.26. Yeah, okay. Let's do on the last little bit here. But also, as it turns out, we know this, if you go further away from a sound source, the quieter it becomes to us. It doesn't sound as loud. And that's because the intensity drops off. It's basically the power that's being emitted, which is just the energy per second. So we could write this as the energy emitted by the source per second, and then, or per time, and then divided by how far away are you. The r is how far away are you, the 4 pi r squared. This is just the surface area of a sphere. So as the energy moves out, it basically moves out in a spherical wave, and it goes out in every single direction. Isotropically is what we're saying here. And so at any point at that same distance away, you would feel the same intensity. It doesn't matter whether you go up by r, or to the left by r, or in front by r, or behind by r. It's still going to be dropping off by that. And then that surface area of a sphere that has a radius r is 4 pi r squared. That's the surface area of that sphere. Okay. So looking at number 29, it says a point source emits waves isotropically, which is what we're saying here. The intensity of the waves 2.5 meters from the source is this. It's a little hard to read. Let's read it in the original. It's 10 to the negative 4. It's 1.91 times 10 to the negative 4 watts per meter squared. So again, that's just an intensity. So basically we're told that the intensity is 1.91 times 10 to the negative 4. I'm going to write that as a joule per second per meter squared. And that should be the power of the source divided by 4 pi. And then the r, we're 2.5 meters away from it. So we can do a quick plug and chug of this. 1.191. Oh, I just entered that in there wrong. 1.91 times 10 to the negative 4 times 4 times pi times 2.5 squared. And we get 1.50 times 10 to the negative 2. And that's going to be watts or joules per second. All right, that's all. Again, not a very long one, but it's a separate one from last time. So I'll upload this video and the notes that go with this as sort of a part 2 of chapters 15, 16, and 17. And then I'll move into the next 3 chapters in the next videos.